Sorry, there we go. All right, so we've got a few people online here. Today is just a retrospective of the course. We're not going to meet the entire time here, but if you do have any questions, please let me know. Online, we are on Piazza, and I'll also go ahead and put up the chat since I don't have so much to show here today. But what is a retrospective? Well, I do these every week, and I do these every assignment. It's what went well, what didn't go so well, and what can be improved for next time. So from your perspective, your opportunity to identify these three things and tell me about them is through the course evaluation. As of this morning, 55 out of 135 students had already filled that out. It is anonymous. Remember that there's also a learning assistant evaluation to go along with it. That's a pinned post on Piazza, so make sure that you're filling both of those out. Depending on the response rate, as you can see here, already everybody has earned 4.07 bonus points. Up to 10 points is going to be awarded, and that's nothing to sneeze at. That's 1% of your grade. So that could mean the difference between a plus or a minus. So, positive peer pressure, get everybody else to fill it out. I take them extremely seriously and go through them. I do full analysis. I do sentiment analysis on them. I just throw them into an online sentiment analysis, like are they positive or negative or whatever. But I also go through and read all of them, of course, all the feedback. And I also do some additional analysis of what, did the pre-prepared videos help you? Did the lecture videos help you? Did the labs help you? What helped you the most, right? And so that gives me a gauge of what to keep, where to invest more of my time on improving things. It's especially important for this last year where we've had this hybrid learning environment, right? Where the vast majority of you have remained online, and a few individuals have chosen to come pretty regularly. It's your opportunity to tell me what went well, what didn't go so well, and it's also your opportunity to tell me about what you think it's going to be like going back to normal. I think 99% of the people out there are under the impression that it should go, or they're of the opinion that it should go back to exactly how it was before. I'm not one of them. I think a lot of good stuff has happened over the last year, and I think that we should keep the good, toss the bad, but keep the good. And now what's good and what's bad? You tell me what you think it is. I've got my ideas of what I think was good and bad, but I want to know some other perspectives here. Think about what you've done over the last semester, right? You've learned stuff. You've improved your skills, your toolbox, basically. Hopefully you've gotten a better sense of soft skills. And what I mean by that is, people skills, teamwork, if you chose to work in a pair. Conflict resolution, if you chose to work in a pair and it didn't quite work out because the other person flaked out, it turned out that they really didn't have the prerequisites because they relied on somebody else throughout Computer Science 1, understandably a lot of people were under stress this semester and maybe they couldn't focus on this class. Instead, they chose to focus on a different class or a different topic or something like that. Conflict resolution in that, you had to set expectations for others as well as setting expectations for yourself, and and coming to some sort of a resolution on the conflict when those things didn't work out. Also coordination. In this morning's class, I pointed out that a lot of people, again, 99% think they want to go back to normal. One of the things I'm keeping, definitely, is online office hours. All my LAs next year will be given the instructions that yes, you'll be down in the Student Resource Center, which will be back open, and the labs, but you will also have your computer there with Zoom open so that people can just stop by. All my office hours are going to be like that. There is no reason to get rid of that. Unfortunately, a lot of people are anti-teleconferencing. For the last 30, 40, 50 years, you've heard about this dream of teleconferencing, never having to leave your home, right? Before COVID, it was always put in a positive light. We just need to have the technology to that point where we can finally do it. And when the technology is finally there and we're forced to do it, Now we suddenly hate it? I don't know. I don't understand it. But anyway, teleconferencing is the future. No, screw that. It's not even the future. It is the present. Right. So get used to it. I met a company, representatives from a company in the VR course because they were working on HoloLens. They developed stuff for the HoloLens. And they gave me their card and, said, as usual, send any students our way that you think might be good for internships or whatever. And great. I looked at their card and they said, you're in California, you're in Los Angeles. That's kind of a hard sell, right? Are they going to move out there just for a summer intern? She said, oh, no, that's just our headquarters. We don't actually have any offices. Everybody in the company is 100% remote. That is the reality. Companies have realized because of COVID that they don't have to spend hundreds of thousands or millions of dollars on big, giant, shiny buildings, right? If they can save money by, granted, they're saving money by making you work from home, but they're not paying for your electricity. They're not paying for the equipment necessarily. Whatever expenses, those are now coming out of your pockets, and that's why companies love it, because they're not going to be spending millions and millions of dollars on shiny, fancy buildings anymore when they can save that money and goes right back into profits. Now, from the worker perspective, of course, that's going to have to be realigned. You're going to have to, all right, well, I'm working from home, great. You're saving a lot of money on commutes, but at the same time now, your work environment has invaded your home. And there's got to be some compensation for that, or there's got to be some understanding, because the traditional understanding is you're at work. That means that's their time, right? You're on their clock. You're at home. Traditionally, that's your time, right? You should not be forced to do work from home. But now, that's the new normal. So how do you separate those worlds? And you've learned about how to do that over the last year. Hopefully, you set aside another part of your home where that's your work area. When you're in that work area, you're doing work. Everywhere else, separate your worlds, right? I don't do work stuff on. I do all my work stuff on this computer right here, but I only do it when I'm upstairs, right? And I leave the computer up there, even though it's a laptop. I'm not taking it down with me. So you have to learn that personal, space, that separation, and those are some of the soft skills, hopefully, that you've been exposed to over the semester. From a technical standpoint, you've hopefully increased your toolbox, second or third, or in the case of SQL, maybe a fourth programming language, and you've got some exposure to object-oriented programming, SQL, database design, and hopefully more Git. Git is now standard. You should be using it on a regular basis, even for toy projects. If nothing else, it raises your profile on GitHub, and headhunters will be approaching you about jobs rather than you applying for stuff. So it's basically kind of like your portfolio, and your presence on Git will actually lead to potential jobs, right? Because even if you just apply for places, you include your LinkedIn profile. Don't include your Facebook profile. Be professional about it. Include your LinkedIn profile. Include your Git portfolio or profile, right? And that gives them something to look at and say, wow, this is a good candidate here. They've got 50 cool projects sitting on their GitHub or whatever. Hopefully you've got a good experience and perspective building a larger project rather than just one-off programs to get you used to the programming. You've got now a experience building a multi-tier CRUD application, create, retrieve, update, destroy application. You've got some technical writing experience, right? Writing with the design document, and hopefully that gave you a sense of how you should approach larger, more complex projects. That design comes first, for example. Hopefully you have a better understanding of technical debt, that if design doesn't come first, then you end up accruing debt, right? That you're taking out a loan on your future time. That you've got to find time to do it right the first time, or you find time to do it over later, right? You have to pay back that debt. that you're taking out a loan, you have to pay it back eventually, right? And that either means you're paying interest in that you're always fighting your own bad design, or you are going back and refactoring it, redesigning it so that it's correct by using more time in the future, right? Or eating your own dog food, basically. If you make a bad meal and it tastes like dog food, then you got to eat it, right? You can't just serve it to other people. Bad practices, hopefully it become apparent why they're bad practices. Not thinking about the design up front, right? And you just start coding and throwing something together. Hopefully that's become apparent why that's a bad idea. Some students are having problems doing the final phase here because they never designed their sales class correctly. So there's no way to get a sales total in order to order things, right? And now they're having to go back and fix those things. Usage of good test cases, test suites, etc. We try to expose you to that through our JUnit test suites on all of our labs. We didn't require the use of JUnit. Did anybody try to use it on their own projects? No? Okay. Well, we did force you to do some familiarity with testing by coming up with those test cases, right, and making it part of the project, so that at least you have something to test against going forward with your code, and you're not just blindly coding in the dark. Even simple things like poor variable names, right? I shared a story of another class that I had where I was trying to troubleshoot this code with another student, and they had this counter variable name with a particular name and so I was assuming when we were trying to troubleshoot it together, I assumed that it was referring to one thing because that's what it said, right? And then finally, after 10 minutes of not getting anywhere, I said, all right, well, I think that this counter is off. How many of these things do you actually have? You go, oh, that's not a counter for those things. That's a counter for these other things over here. You go, well, then why the hell did you name it that? Right? We've been sitting here spinning our wheels for 10 minutes because of bad variable names. It's the simple things like that go into design, right? That hopefully you've gotten out of that bad variable naming habits out of CS1, but it's something that is going to continue to persist, right? Think of good names. Just name it what it is, whatever it says on the box. Hopefully you have some experience with over-engineering. Remember the Yagni principle? You ain't gonna need it, right? Engineer just right, like Goldilocks it, right? Not too hot, not too cold, Goldilocks, just right. Bad database design. Maybe we didn't see, like I said in the morning class, we didn't see that much this year with bad database design because the average score I think was an A for that phase. Almost everybody got a really good design or a simple design. In contrast to say the phase 2. The object-oriented design. So I think that a lot of people learned from the object-oriented design into the relational model as well. Right? Question online here, once the semester has concluded, would it be beneficial to make our private project GitHub repo public so potentially interested parties can view it as part of your portfolio? If that's the only thing that you have, yeah, sure. But eventually you're going to want to replace that. Most employers are not going to be interested in your class projects unless it's something much more substantial than what we've done here. Right? Hopefully you have a better appreciation for the scope of larger projects, working and coordinating teams, et cetera, et cetera. Overall, you're better coders, better designers at this point, hopefully. And of course, you've picked up some self-organization skills along the way, hopefully. This is the first semester that I introduced the use of a Gantt chart. We didn't require it. I just wanted to show it to you as it's one of many dozens of different ways that you can manage projects. And Gantt charts it seem natural because we have these sprints, but we also have a larger overall project. So following the Gantt chart, I don't know how many people followed the day-to-day updates that we made on Piazza throughout the semester following the Gantt charts. But if you found that to be a valuable tool, go ahead and adopt it and use it later on. Again, there are dozens of things like this. When you get into more agile development, say in software engineering or something like that, you'll find that there are lots of these tools out there. They're burn down charts. Their full sprints would have you at the beginning of the sprint committing to certain tasks and then burning them down throughout the sprint, and then doing a retrospective at the end. That's basically what I've done for you, right? Having a retrospective after each assignment. The Gantt chart tracks I'm committing you to things at the beginning of the sprint, because I designed the project for you rather than in agile development. It's more self-managed, right? You're given the project, and then then you have to come up with a plan for executing that project yourself. And this is a logical order that I gave everybody that I've designed and redesigned over the years, but whatever. Another technique that I did not talk about this semester was the Pomodoro Technique. So it's more personal, much more smaller order, where if you focus on something for, say, 3 hours straight, if you study for your calc exam or you're doing your calc homework for 3 hours straight, over that 3 hours, your productivity starts high, but then it starts to go down, right? Because you've been doing the same thing over and over again. Maybe you hit a wall, right? And now you're just spinning your wheels, so you're not making any progress. The Pomodoro Technique has you chopping your time up into discrete increments, where it's based on this Pomodoro, this Italian tomato timer. Right? We would call them egg timers, but in Italy, apparently they're shaped like these tomatoes, so they're Pomodoros. And they're about 30-minute timers. So you set the 30-minute timer, you work on that one thing, your productivity remains high. Ding, right? You context switch and go out, take a walk. Then you come back refreshed. Or you context switch and do something else. You do calc for a half hour, then you do CS for a half hour, then you go and do history of rock and roll for a half hour, whatever else you're doing, or or take your personal time and play video games for a half hour. That's perfectly fine. Planning for recreation is recommended, actually, right? Don't cut what you enjoy doing, but make it part of your daily plans, right? And that's the Pomodoro Technique, where you split it up into discrete increments so that you're always maintaining a, maybe not super high, but you're maintaining a level of productivity, right? As far as agile development, another one would be keeping Kanban charts, if you've ever heard of those. Basically task boards. I do it in the form of just a to-do list. I have a to-do list, and as I go down, I check, right? Everybody should have some sort of self-organizing tool like that, right? Hopefully you've been exposed to additional techniques and tools. If not, sorry. You've also seen the consequences of insufficient testing. I like to say that if you can run code, you can run tests. That's like a lab. We give you the tests. You can run them just by hitting play, right? That's kind of the exposure level kind of idea with test-driven development. If you can write code, you can run repeatable tests, right? So if you write code, and typically what you do is you do an ad hoc test, right? You test, does it compile, does it run on this one input, and does it run, right? That's an ad hoc test. But if you can write code, then you can write a test in code, right? So you can write a JUnit test so that next time you run it, you don't run it ad hoc, you just hit the button and it runs again. Did I break anything? Run? No, I didn't. Great, we're still good to go. If you can read code, then you can write proper unit tests, right? And using a formal test framework so that you don't have to do all that boilerplate stuff going forward. And note here the level, right? Down here is the highest order cognitive ability, and up here is the lowest order cognitive ability. So if you want to think about them in low to high up here, just running code doesn't take too much cognitive ability. Writing code takes a little bit more because you need to know how to code. But what's even more what requires even more cognitive load and cognitive ability is actually reading code. It's kind of the opposite of, if anybody's familiar with Bloom's taxonomy. Bloom's taxonomy says that you can, down here at the lowest level of cognitive ability, you have recall. In other words, can you memorize something? And all the way up here, you've got creation. Can you create something new? And somewhere in the middle, you've got analysis. Can you read and understand something, right? These two are actually flipped when it comes to development, because writing code is actually relatively easy. Reading other people's code and understanding what they were doing, that's actually a lot harder, right? So that's why I put it in this order here. Right? It's actually quite the opposite of Bloom's taxonomy when it comes to computer science, at least in my opinion, and there are a couple of papers on this too. Right? These are the skills objectives from the original syllabus. Hopefully you've picked them all up. You should be able to pick up and learn a programming language on your own. So now you should be able to go out and say, I really want to do some game development. So pick up Unity and C#. Or I want to do some web development. So pick up some JavaScript, all right? You should be able to do that on your own much, much easier now that you've got 2 or 3 different programming languages under your belt. You should be able to recognize, use, design, and appreciate programs with an object-oriented programming flavor. Even if you're not in an object-oriented programming language like, say, Python, you're still going to want to create classes, and Python does allow you to create classes and use them in an object-oriented way. You're going to want to use them in a mixture of ways, right? Maybe not inheritance. Inheritance is kind of discouraged in Python since you don't have strong typing, but whatever. Be able to design a database backed application from scratch given a general problem statement. That was exactly what the project was all about this semester. Be able to understand and implement basic data structures, as well as recognize how and when to leverage appropriate data structures, and I'll add on to that algorithms. You should be able to identify and analyze basic algorithms as well. Right? I guess that I don't need to add it if it's the next bullet point there. But basically, again, after Computer Science 1, or as general problem solving, when you approach a problem, what's the first question you should ask yourself? Is this problem already solved? Is there an off-the-shelf solution? After Computer Science 1, you should be asking yourself, how do I solve this problem? What kind of data structures can I take off the shelf to bear to the problem and let it solve it for me, right? Put stuff in, take stuff out with a heap, and you've got a sorting algorithm, right? And of course, knowing which data structures are appropriate to use at which and how to use them, because it's the difference between, as we saw, if you use a linked list, it's going to take you 20 years with this particular algorithm over here. If you use an array-based list, it's going to take you 5 seconds, right? So being able to understand those situations is what separates coders from, computer scientists, computer engineers, software engineers. Right. Again, the central theme is smart data structures and dumb code are a lot better than the other way around. That's Eric S. Raymond from The Cathedral and the Bazaar. That, along with a bunch, I could recommend a few books as far as design or code philosophy goes. Right? They don't talk about particular languages or particular designs or anything. They talk about the philosophy of approaching design and code and stuff like that. And The Cathedral and the Bazaar, the idea is where does good code come from? Where does good design come from? Does it come from the learned folks up in the cathedral on high who then disseminate their ideas to everybody else and were forced to use them? That's one model. Or does it come from the bazaar, the normal people, or all of us normies working together and crowdsourcing stuff? That's where the good ideas come from, right? And those are 2 different models that you can follow, and he talks about those 2 models and why the bazaar is actually better. Because more eyes on code is always a good thing. That's why I like you to work in pairs, right? That's why in labs, work with as many people as you want, right? More eyes on there's a statement, I forget how it goes, but with more eyes on the code, all bugs are transparent or something like that. That eventually, if you have enough people on a project looking at the same code base, all bugs will be fixed, right? And all issues will be addressed. Simply, tightening up your code and not letting anybody see the source code or whatever, and going up to your cathedral and then saying, here's our build, here's our jar file, go ahead and use it, plebes, right? That's not a good model to follow, because now no bugs are transparent, right? But I could recommend a couple of books like that that go into the philosophical ideas surrounding code and computer science and stuff like that. By the end of this course, you should be able to approach a reasonably complex problem and ask design questions first, like what entities or objects should I design and how should they interact then together? What data structures are the most appropriate or efficient to use? Again, the big takeaway here is you may have done some things wrong or a lot of things wrong, but that's okay. You've learned from that experience, and next time you'll do better. And that's what school is all about. That's why I like to give that resubmission opportunity so that you can fix past mistakes. You're still in a learning environment. You're still in school, and making mistakes is perfectly fine. When you get out into the real world, right, and in school, if you blow off an assignment, fine, your grade goes down. Maybe you have a resubmission opportunity or whatever. Blow off 2 assignments, 3 assignments, okay, your grade suffers big time. Maybe you have to take the course over, but you're not kicked out of school, right? If you're in a job and you don't do your assignment for 2 weeks, you don't do your assignment for 2 weeks, you don't do your assignment for 2 weeks, then your next assignment is updating your resume. So, you're still in a learning environment, and it's still okay to make mistakes and learn from those mistakes. This is both the honors and the main section together here. There's at the census date, that is the date after which you could get a full refund or something like that, I forget. There were 159 total enrolled. Right now we have 133 still enrolled, so that means 26 folks have withdrawn. Now some of them, a minority, but some of them withdrew with good grades. And they realized computer science is not for them, or they needed to focus on something else, or again, COVID, they had to refocus their efforts on something else, and they'll be back. And if you're out there still watching, please do come back eventually, right? But otherwise, 66 A's. So that's, what is that? Like 2/3, or no, sorry, 1/3. 1/3 of 160 is, yeah, that's over 1/3. Over 1/3 are going to get A's. This does not reflect the last 2 assignments. This just reflects after assignment 6. 36 B's, 13 C's, 3 D's, and 15 unfortunate F's. So that gives us a DFW rate of 27.7. That's a little bit higher than historical averages. With computer science too, it's about a 20% failure rate. It's unfortunate, but it's reality. If anybody had the golden key to unlock the mystery of why that is, or what we can do to turn that around, I am all ears, right? That's a little bit higher probably because of COVID this year or whatever. But use your student evaluations to tell me, why do you think it's high this year? Why do you think it's high in general, right? You've experienced each other. You've experienced students who've not done so well. What was the factor in them not doing so well? Yeah?
Try not to have classes during a global pandemic.
Well, unfortunately, even in a regular year, it's still 20%. And computer science 1 is even worse. It's usually 40%. Thankfully, in last fall, it was actually no higher than usual in fall 2020 than for computer science 1. But it's an inverted normal curve. It's an inverted that you have a lot of really high grades, you have a lot of really low grades. And it's bimodal, right? It is bimodal distribution rather than a normal distribution. Normal distributions are only really expected from like when you've got a grading curve or whatever, where you're forcing everybody to have a normal distribution. I don't believe in that. Most people don't use that. That's it's arcane from like the 60s or 70s, where everything has to have a normalized curve or something. Nobody does that anymore. So it's normal that it's a bimodal distribution. It's just that we would like to get this second hump down as much as we can. Anyway, you do have assignment 7 and design documents still to turn in tomorrow by midnight. Take care with your design on assignment 7. If you have been following everything that we've done And if you've been listening to everything that has been said on Piazza, literally, assignment 7 is no more than 10 lines of original code. Right? You should not be writing original, as in if you use what we've already given you as a basis. Really, you only need to write about 10 more lines of code, and you are done with the assignment. Right? Within the class, of course, probably have another 30 lines of code to use your class or something like that. But it is a test of your design skills at this point rather than coding skills. So keep that in mind. The design document, make sure that you review all of the feedback. Unfortunately, some of the feedback was not all that useful or great from some of the iterations. I've only found out about this recently, but make sure that you are reviewing what feedback you did get on your design documents. And more importantly, review the feedback in our retrospectives, because I wrote those and I made sure that all of the bad habits or all of the bad things were highlighted. So make sure that you're reading those retrospectives for your final design document draft. There is no final exam. It was cut for, because of COVID, the student self-care resolution, I think was what they was called. Anyway, I cut it. I didn't like them anyway. They were multiple choice Scantron tests, and I think in the future I'm not going to have them anyway. So this is a skills-based course, and how do you demonstrate and assess skills? By doing things, right? It's not a memorization course where we have to examine true or false, or pick from A, B, or C, or whatever. And so it was never a good assessment technique anyway to begin with. Assignment 8, there have been a lot of questions about it. Again, it is required but not graded. You don't have to turn it in. We're not even going to look at them. I think one person has turned it in, and I took a look at it, and I complimented them on their handwriting. A very nice handwriting. I couldn't believe like if it had not been like a phone snapshot of it, I would have thought that they had some fancy script that they generated or something, because it was that good. But it was definitely handwritten. It's required in that material is going to be expected in the future program, right? That you're going to be expected to know big O analysis. You're going to be expected to know binary search trees, etc., because they're probably not going to be covered again. Right? The final stats will be posted. Again, these are preliminary stats, the current stats without assignment 6 and 7. It does include labs. Remember, we are dropping the lowest lab grade. No bonus for having all 15 labs, or 14 labs, I guess there were. Right? So thank you. Thanks to all the students who helped on Piazza. You are beautiful. I can't tell you, that's why I love using Piazza, is because usually the students become the bulldogs themselves, that they start answering questions, and all I have to do is endorse the answer. Yes, that's the correct one. Or in the rare occasion, do I have to come in and say, well, no, that's not exactly right. Okay. But thank you to all the learning assistants and course leaders. Hopefully you did take time to nominate your favorite learning assistant for a CSE award. Those will be announced maybe in a couple of weeks, I forget, after finals week. So if you didn't, I think that it's closed now, unfortunately. But go ahead and call them out in your student evaluations if you haven't filled those out already, right? Joey Jojo was really helpful. Special thanks for him, accolades, because the learning assistant program does have access to that stuff too, and they do use that in their hiring and promotion process. There is a promotion process in there that you start out as an LA, and then you can become a course leader, and then you can become like Ryan and JL were the course leaders for this course. And then you can become a senior leader where you help with the program itself. So it's a really good program. Make sure that you're filling out those evaluations and calling out your favorite learning assistant. All right. Thank you for everybody who took this class. Again, it's weird, stressful year, but everybody survived, and next year we'll thrive. Right? Hopefully we do take the good that we learned about this year. And that it's retained, and whatever bad we learned this year, we throw that out. But ultimately, have good luck in your finals, of course, if you've got finals. How many people have finals? Okay, what courses still have finals? Calc? Okay, calc. You'll never meet a math teacher that didn't like a nice summative assessment like that. Who else? The 235. Okay, so discrete math. Again, math. Physics. Okay, physics. All right. So physics 1, 2, 3, or 2. Okay, so calc-based physics, I assume. So, oh wow, what is that? No quantum mechanics yet, right? No. Okay. So, I don't even know what that would be in there then. Oh, okay. Electricity? Okay, so like Ohm's law, or magnetism and all the conversions between all of them, but maybe the standard model. No? Okay.
Just open the quantum mechanics book, and then there's just a smaller book inside.
No, you open it up and it all disappears because it collapses into its quantum state. So, have a great summer. Good luck on the rest of your finals. Any questions? No comments on Piazza? Yeah.
What is some like elective courses that you would recommend?
Usually after, so I don't know if you've taken 230 or 231 yet. 230 for computer engineers, 231 for CS and CSE. You've taken 230? 230. Okay. There, I think, I don't know if they're an Altera board or if they're an Arduino board. I think that they might still be on Altera boards. But you can get yourself an Altera board or an Arduino over the summer and start playing around. Or get a Raspberry Pi, a Raspi, and start playing around and making the light blink. That's the Hello World program of embedded systems, right? Whatever. But if you've already taken that, then so CE. I don't know what the EE courses are like. ELEC. I'm not sure. There's about 16 credit hours that you have to take of EE courses, electrical engineering courses. But electives you really only open up after 310 and maybe 361. That's computer science 3, and 361 is software engineering principles. Networking is popular. In fact, I think it might be required if you're CE. So that's 462. Data structures, like computer science 4, basically, that's 423. That's a good one. It really depends on what your niche is or what you're interested in. Like robotics. No, not robotics.
Probably more software stuff.
Oh, so more software stuff. Okay. There's usually a special topics course taught by some industry guy about Amazon Web Services.
Yeah.
I don't know if Hassan does it anymore, but he might do internet programming is what it is, and I think it's just like a Java script, Java stack. I don't know. It should be updated if it's still that, but whatever. I don't know. Ask on Piazza, because it also really depends. I mean, our 4-year course plan is thrown out the window. We don't have a 4-year course plan anymore because there's been so many new faculty. Like diligently look at the course catalog, because we're going to have 6 new faculty coming in next year, and all of them are going to have special topics courses, because that's what a new faculty does. They do something that is related to their research. A lot of them are not a lot of them are software engineering researchers, so it's not going to be software engineering focused. It's going to be a lot of hardware security, maybe. Networking, network security. Nurnimesh, he's my office mate just a few doors down. He does network security, network hardware security, a lot of that. So lots of low-level stuff. I don't know who's responsible for it now, but every year Nurnimesh does it, I think. Cryptography and security, so traditional crypto, like RSA, crypto systems, DES, AES, encryption, cryptographic hash functions, stuff like that. I don't know. What's your interest?
I'll get back to you.
Okay. So that's another plug for joining the CSE Discord. I don't know. I don't know how. I don't have a link to it, but I can show you. It's a public Discord, so it doesn't matter if I show you. Here, this is it. Yep, UNL CSE community. So here we go. Let's see. This is general. So students, please recommend to your juniors any cool technical electives. There you go. We'll see how many answers we get. Probably none.
Probably not this week.
Maybe, I'm anticipating none, period, because that Discord is kind of dead. You don't see too much on it. Yeah.
Is there any like topics that in this class that you felt like we probably should have spent a little longer on?
That's a good question.
Teachers definitely feel that way.
No, I mean, I think because I cut the exams that I got to everything that we normally get to. Maybe we cut a little bit off the end on trees. In that, if I had more time, I wouldn't cover any more new topics. We would just go into more detail in the current topics. For the H version, yes, there are usually like 3 or 4 advanced topics that I get to, that because we go faster. We didn't have that luxury this year, so I cut those. For example, I usually have one lecture showing you asynchronous programming, and then asynchronous programming in parallel programming, creating threads in Java, and farming out work to different threads so that you can. And the demonstration I usually do is I show you how that I have 800% CPU usage on my own personal computer here because of four cores with hyper-threading gives me 8 processes at once. And basically, it's if you can parallelize things, something that would take 8 hours now only takes one hour on 8 different processors. And so you double your processors, and now it takes half the time. Double them again, now it takes a quarter of the time. And you can, as students, go over to HCC and, well, not go over there, but go to their website and get access to their cluster. You can get 100 nodes. You can get 100 cores and run something on those 100 cores all at once. All you need to do is sign up for it, and you might be given a lower priority than the paying clients out there, but it is possible to use the supercomputer power over in HCC. Yeah.
Do you have recorded lectures for that?
From last year, I think I did it. Yeah. Another one would be JPA. I usually go over that. I think that there might be a recording there somewhere of that. Another one would be the HTTP protocol, hypertext transfer protocol. That you do your stuff in PHP in Lab 1, and I use that as to show how that works behind the scenes. How your browser makes a connection through TCP/IP, and then on top of that speaks in HTTP to the server asking for something. And you can actually do it manually. I think I might have shown it briefly here, right? You can open. I can just show you really quick. Telnet is a TCP/IP thing. Telnet to cse.unl.edu on port 80 is what HTTP listens on, right? Oops, I have no Telnet. Okay, I'm not going to be able to show that. It's not installed here. Yeah.
So the goal of this was like smart data structures plus dumb code is better than the other.
Yep.
I was wondering, a lot of these things that like we learned, like we didn't really like see how to do that in like C, like how we did last semester. Is there any way to do a lot of what we did in C, or did that just
C is not object oriented, so I mean you can do some of what you do. It's just that you have to do it in a different way. So for example, you can create a tree, or let's just take a linked list. You can take a linked list. How? Create a structure that has a pointer to the object that you're storing and has a pointer to another structure, right? That node structure, and call that thing a node. Now you've got, and then string them together, and now you've got a linked list, right? The problem there is that you don't have an object, so you only ever have the head. You don't have methods that act on that object. Instead, you have to say, add method, I have to give you add an element. I have to give you the element, and I have to give you the list, right? It's kind of stupid because now it's broken it's weak encapsulation. It's outside the class. But yes, you can do stuff. Anything that you can do in one language, you can do in another. It's just that it might be done in a slightly different way, and because that's the programming language paradigm. In a programming language like, say, Python, well, generally you don't want to roll your own linked lists or data structures anyway. But in a programming language like Python, it has built-in maps. They call them dictionaries. It's got built-in lists that are efficient. Everything at the end of the day is a hash table. So everything's efficient. There's like PHP. There's no binary search built in. Why? Because there's no lists, right? There's no arrays. You only have associative arrays. And associative arrays under the hood are hash tables. Hash tables are already efficient. You don't need binary search, right? And so that's why there is no binary search. So other languages do things slightly differently, and you just have to learn the nuances thereof, right? And that's why just mere coders, they don't know that stuff, right? That's why that quote that I showed you the other day, if you wanted to become a world-class programmer, program every day of your life for 10 years. Or program every day of your life for 2 years and take a data structures and algorithms class, right? So that kind of knowledge and experience is worth a hell of a lot more than years of experience. But yeah, you can do it, anything that we've done in any language. Any other questions? No? Well, then again, thank you. I'll see you maybe next year or over the summer, or maybe in a couple of years if you ever want to take that VR course. Or if you, I don't have a sign up for that, but I am going to do it next year with the new person over in Carson Center. So please drop me a line if you're interested in taking that course. Maybe ask about it on that dead Discord. Oh, somebody upvoted it. Aaron upvoted it. The up arrow means I agree with this. Please, somebody else answer because I don't want to answer. All right. Have a good weekend and have a good summer.